Hello Year 12 and welcome back to the second video here for our first topic of the HSC year. We were looking at simple interest in the last exercise, being the first exercise, and now we're looking at compound interest today. Again, I'm sure you've seen a little bit of this before. Now, the difference between simple and compound interest is essentially that with compound interest, interest is earned not just on the principal, but the principal and any previous interest. Right, so we earn interest on the interest. Now, this means that we have a different formula. It's not PRN. This time it is A equals P outside of 1 plus R to the N. We get an exponent this time, right? We have to use indices. Right, we raise it to the power of N. Also, you might remember from the previous exercise, from the previous video, that sometimes I used A to represent the total amount repaid. And that's what it represents in this formula. So the simple interest formula calculates just the interest, just the extra that has to be repaid, but the compound interest formula calculates the total to be repaid. Okay, so A includes the principal and the interest. Same as before, P is for principal, R is the rate of interest expressed as a decimal, which will be our percentage over 100. N is the number of terms. We need to be extra careful with these questions, right? There's a little tip down here. Extra careful that we match up the units of time for N and for R. So it might say the interest rate is, say, 12% per annum, but it compounds monthly. Now that means, right, that I have to convert my annual interest rate to a monthly interest rate. Right, and I do that by dividing by 12. So it would be, my interest rate then would be 1% per month, not 12% per annum. Now that compounding frequency is important. It's a very common way that examiners sort of complicate these questions. One more little thing that we talk about is instead of A for amount, sometimes, and I think your formula sheet uses FV for future value. Right? It's exactly the same as the amount. It's what you will owe at some stage in the future. And PV is for present value, which is the same as the principal, what you started with. Righto, let's jump through and look at some examples here then. So Molly invests $7,000 over 5 years, compound interest rate 4.5% per annum. Calculate the future value, right? It's not saying calculate the interest, calculate the future value. That's nice and straightforward. After 5 years, now, interest is calculated quarterly. This is really important. Quarterly means every 3 months. Or 4 times per year. Right, that's what quarterly means. So I've got to change this interest rate from 4.5% per annum to something per quarter. We'll do that by dividing it by 4. Okay. So my future value, we'll use this version of the formula. The future value is equal to my principal, 7,000. That's nice and easy. 7,000 outside of 1 plus, now it's R. This is going to be 4.5 divided by 4, right? That's my quarterly part, over 100. Okay, it looks pretty complicated like that. Well, that's just how it is. And we raise that to the power of N. Now again, it's compounding quarterly. So how many quarters are there in 5 years? Well, it's 5 times 4. So it's going to be raised to the power of 20, but we should, if we're careful, be able to type that expression into the calculator just as it appears. Let's have a go at doing that. Okay, I'll just drag this out of the road so we can see them both at the same time. So here we go. I want to say 7,000 right, times in a bracket. Now 1 plus, so far so good. I'm going to put a bracket in here and say 4.5 divided by 4, close my bracket and stick that over a fraction, over 100. Now arrow across and to the power of, so this little button here, the XY one here, you can see, to the power of, I'm going to put a little bracket, 4 times 5. Now, you could very reasonably do 4 times 5 in your head. That's fine. But just to show that we can type all of those things in here on the calculator. One of the advantages of these Abacus calculators, or the Casios, is that you can review that expression. You can see on the screen there that looks very much like what I have written on my page. Okay, so equals here, and we get the total amount. Now that's not the interest, that's the future value, if you like. Okay, that's the future value, and it's 8,755. We'll round it off to 25. So Molly is investing this time. It's not how much she has to pay, it's how much she's going to have saved. Right? She put $7,000 in the bank. 5 years later, she has $8,755. Radio. Now, example 5, calculate the present value of an investment that has a future value of $500,000 over 8 years with an interest rate of 8.5% per annum compounded monthly. What does this mean? Well, I've got the future value. Let's say I'm planning in 8 years' time to have $500,000 in the bank. My bank is going to give me 8.5% per annum. So how much do I need to put in the bank now so that it will grow to $500,000? Now, this is my rate here. So my rate is going to be 8.5. Now it's compounding monthly, so it's 8.5 divided by 12 over 100. That's what my rate is. That's a pretty terrible looking R. Let's try to do a neater one. So my rate, 8.5 divided by 12 over 100. I need to calculate the present value here. I've got my future value and my number of terms. Be careful that you don't miss any of these because your answer will get very different. Now it says 8 years, but it's compounding monthly. And when it says compounding, right, that's what you're locked into. We can change the interest rate, right? We can convert the interest rate. We can convert the number of terms. We can convert those units. We don't convert the compounding frequency. So my 8 years is 8 times 12. There's a shortcut this time. We know that 8 times 12 is 96. So let's write out our formula. We can substitute in. I know that my future value is 500,000, so I start with that. 500,000 equals my present value. So just say PV outside of 1 plus 8.5 divided by 12 over 100, all to the power of 96. Now this is looking pretty complicated. But if I take all of this part of my expression and I divide both sides by that, my present value then equals, we'll have to scroll a little bit here, it's 500,000 divided by or over 1 plus 8.5 divided by 12 over 100, and all of this to the power of 96. Looks pretty complicated. It's tempting to punch some of those numbers into your calculator and simplify it, right? But you're likely to get some either recurring decimals, some big recurring decimals. And raising something to the power of 96, as we're doing here, right, is going to make a huge mess of any rounding error. So even if you carry a lot of decimal places, right, you're still likely to introduce a pretty significant error. So as much as possible, right, try to do all of the calculations at the end, or at least keep everything on the screen or saved in the memory of your calculator, right, not rounding it off and writing it down. So here we go. I should be able to, with a little bit of care, punch that into the calculator. Let's have a go at doing that. So my present value will be 500,000 over, it's my fraction, now, bracket, 1 plus, another bracket, 8.5 divided by 12, close that bracket, over 100. Now just having a look at what's on the screen there, I can see that I haven't sort of combined things with my numerators or denominators. So far this is still matching what I have written. Okay, we can see that. Now I raise that to the power of 96. You can see there on the screen that looks very much like, right, what we have here is very much like what we have here. 500,000 over 1 plus 8.5 divided by 12 over 100 to the power of 96. So we just need to press equals, and there we go. 25,000, oh sorry, $253,916.41. And does that make a bit of sense? Not too bad. This tells me that I start with about $250,000 and I end up with about $500,000. So over 8 years with a pretty generous interest rate, we have just about doubled our money. Present value, $253,916.41. Okay, just check with the question that we've answered it in the form that we've been asked. Calculate the present value, and there we go. Yep, my present value is $253,916.41. We've rounded it to the nearest cent, which is pretty sensible. Okay, now, one last example here, and we will be done. Melvin invests $10,000, 10 years, compound rate, 7.5% per annum. Calculate the future value of the investment and the interest earned. Okay, this is nice and straightforward. That's my principal. My compounding frequency doesn't say, so we're going to assume that it's annual. Okay, so n equals 10. My rate, we can say it's 7.5 over 100. Wonderful, and I've just got to calculate the future value. Now, the interest earned, that's not very complicated. Two parts to this question, because it says to calculate this and that. That's fine. So first of all, our future value is equal to 10,000 outside of 1 plus 7.5 over 100. And if you like, you can go straight to 1.075. Once you've done a few examples here, you'll probably see that's the fastest way to do it, or it's quite easy enough, to the power of 10. So my future value, easiest calculation we've done for a while, is 10,000. Now, because I can do some of these things in my head, 1.075, right? 7.5 over 100 is 0.075, and I can add 1 to that pretty easily. 1.075 to the power of 10, I can't do that easily. And here we go, 20,610.32. 20,610.32. Okay, does that make sense? $10,000 goes in. 10 years later, $20,000 is in there. We've, again, roughly doubled our money. That's fine. Now, that's my future value, done. But the interest earned is the difference between what I started with and what I end up with. So my interest is equal to the 20,610.32 minus the initial, or the present value, the principal that we began with, minus the 10,000, don't need a calculator here, is $10,610.32. Rightio. So that's compound interest that we've looked at in this exercise. Previous one, simple interest, compound interest, some things to watch out for. The really big thing we've got to watch out for with compound interest questions is where it quotes the interest rate per annum, but it says it compounds, say, monthly. You need to change the interest rate to monthly and the number of terms to months. So there's two things you have to change. One of the numbers you'll divide the interest rate by something, and you'll multiply the number of terms by the same thing. Okay, that's it. Got any questions? You know what to do. Ask your teacher in class. I'll see you around.